So let's move on now and let's look at parallel lines and transversals. So we've two lines here, we've L and M, and they're denoted to be parallel in that they'll always be the same distance apart by these arrows here, as well as the mathematical symbol L is parallel to M. So L parallel to M. Okay? And now let's look at the angles associated with parallel lines and this notion of a transversal. What is a transversal? A transversal is a line that cuts through the parallel lines, the transversal T. Okay? And there's certain rules associated with transversals that go through parallel lines and the angles they generate. So let's have a look at those. Okay, the first rule is that if I have two parallel lines and a transversal T cutting through both lines, that the rule is that the corresponding angles that the angles that are created by the transversal as it goes through both parallel lines, the corresponding angles are equal. So they're the same. If you could imagine that you could cut these four out and place them on top of here, the angles on top of each other are the corresponding angles. So one corresponds with one there, and 2 corresponds with 2, 3 with 3, and 4 with 4. Okay, as we've written here. And here again are two parallel lines going in another direction, but the corresponding angle here, shaded angle, is equal to the corresponding angle there. We also have this notion of alternate angles. These are angles that are between the two parallel lines. They're enclosed in this area here, and they're alternate, so they're on opposite sides of the transversal T. Okay, these are between the parallel lines here, and they're on opposite sides of the transversal. And this chapter mentioned our first theorem, which asked us to note that if a transversal T makes two equal alternate angles, then these lines must be parallel, and that's known as a theorem. It's the first theorem we've met in first year maths. And let's look at interior angles now. Now we have two parallel lines. The interior angles they're between the parallel lines, but this time they're the same side of the transversal T. Okay, so they're always between the parallel lines. If we're going to call them interior, they're always on the same side of the transversal, like here, and they actually add up to 180 degrees, which is very important. Okay, so if we look at this example here, if we try this, we have 120 degrees, we have G, E, F. To solve those, we can say G is 120 because they're vertically opposite. We can say E is 120 because they're corresponding angles, and we can say that F must be 180 minus the E, which is 120, so it must be equal to 60. That's applying the straight line rule. We could also apply the interior angles rule here, because we know that G is equal to 120. We know that they should add up G and F to 180, so F must be equal to 60. Here's an interesting problem from that chapter, where we have a triangle, a three-sided triangle, and we have this side is parallel to this other line that dissects this straight line angle here. And we're asked to find G, E, and F. Well, the first thing, to find G, the sum of three angles in a triangle is 180, so G must be equal to 180 minus these two. G is equal to 72. Because these lines are parallel, this line actually is acting as a transversal, and we can see that F corresponds to G. So F, if G is 72, F must be equal to 72. And if we apply the straight line rule now, we know that This angle is 72 and this is 72. So E must be equal to 180 minus 72 plus 72, and that's equal to 36. Now, let's look at triangles and problems associated with triangles and rules associated with triangles. So we have a triangle here, 3 sides, 3 angles, A, B and C. And we just note that the corners of a triangle, and each corner is known as a vertex. So this is the vertex C, and the corners are known as the vertices of the triangle. Where the lines that create the triangle join are known as vertices, and the triangle is created by lines which are really line segments. So this is the line segment, remember the square bracket notation, BC. And important rule is, we've met it already, but the sum of the 3 angles in a triangle is equal to 180 degrees. Types of triangles. So there's the isosceles triangle, where 2 sides are equal and the angles opposite those equal sides are equal. An equilateral triangle, all sides are equal, all angles are equal, and they are 360 degrees, and this single dash on each side tells us that all sides are equal, whereas for this one we might do a double dash on each side to say that those 2 sides are equal. We have a right angle triangle, always has a right angle in it, and that we need to note that the side opposite that right angle is always known as the hypotenuse. And then we have a scalene triangle, which has 3 unequal sides and 3 unequal angles. And there's other types of triangles, but they're not for this course. We have an acute angled and an obtuse angled triangle as well. And here's an important rule we met with in this chapter, and that's say if we have a triangle and we extend, say, the base of the triangle out here, we have an exterior angle formed here outside the triangle. And the important rule is to say that the exterior angle here is equal to the sum of the 2 interior remote angles. So this angle equals this angle plus this angle. Okay, and I have them A and B. So this angle is equal to angle A plus angle B. And here's an example. Find x. If that's 72 and that's 84, x, the exterior angle, sum of those, 156. Here's a right-angled triangle. Okay, this one, and we need to find B. Okay, so this is 34, this is 90, B is equal to 180 minus 34 minus 90 is 56 degrees. Here we're looking to find B. Well, that's equal to the sum of of the 2 interior remote angles. So B is 101 degrees. Here is a larger problem here, where we have a triangle with an angle of 40, A and B, and we need to remember that the sum of 40 plus A is equal to 180, so 40 plus 2A equals 180, so 2A must be equal to 180 minus 40 is 140, A therefore is 145 to A is 70, and if A is 70 here, then B must be 180 minus 70, and B must be equal to 110. Another problem for consideration here. Again, we have one side of the triangle extended and an exterior angle formed. It's equal to the sum of these 2. That angle E is equal to this angle plus that angle, 79 degrees. Our final example here, we have an isosceles triangle. So it's an isosceles triangle. This angle is 36. We know it's isosceles because these 2 sides are noted to be the same length. So if it's isosceles, if they're the same length, then this angle here must be B also. And B plus B, 2B, is equal to 180 minus 36. Or 36 plus 2B is equal to 180. So we can work out that 2B is equal to 144. B must be equal to 72 degrees, because 72 plus 36 is 180.